Good evening, Titans. And today we're going to be discussing compound inequalities. And compound inequalities is more or less when we have two inequalities written in one sentence. Just like you'd have a compound sentence in English, where you'd have a subject and a verb, and a subject and a verb. All right. Well, a compound inequality falls right along that same lines, where you're going to have two inequalities written as one sentence. We'll learn how to graph solution sets to compound inequalities and to also solve compound inequality. So, a couple definitions here. A compound inequality is two inequalities are combined into one statement. The words and or are used to describe the relationship between the two parts of the inequality. Now, if the word between them is and, then it's called a conjunction. And a conjunction, when it has the word and, it means it's the intersection of the two graphs, or where do the two graphs overlap? If you were to graph both inequalities on a number line, where would the two graphs overlap? Intersection, obviously, is the overlapping of the solution regions. Now, if the word between the two inequalities is or, then it's called a disjunction, like they're disconnected. And this is the union of the two graphs. And the union is the total region of the graphs. All right? So, for example, in a conjunction, if we would have a graph going this way and a graph going this way, where they overlap is a solution. And in a disjunction, you'd have a graph probably going one direction and then going this direction, and the union is just everything that's being graphed on the number line is your solution. And so what's this look like as a Venn diagram? Well, an and, again, we have set A and set B, and a conjunction, or the word and, means what do they have in common. Or means the union of them. So it would include, if they happen to overlap, what's overlapped. But a lot of times you may just have two things and they don't have anything that overlaps in the middle, but you would graph both pieces. So what's this look like graphically? Well, first of all, when we see a compound inequality written like that, this actually means it's an and. Only conjunctions can be written without the word being used. And so to rewrite this using the word and, again, x is in the middle here, but x, and we don't want to upset the alligator here, is greater than a negative 4, and x is less than 2. And so when we go to graph that, we have negative 4, open, and it's greater than, less than 2, open, less than 2. And so where they overlap, so my solution are the numbers between negative 4 and 2. Now where it's an or, I have x is less than 2, or x is greater than or equal to 5. And my solution here is that graph. So the only parts that don't work are the numbers between 2 and 5. So in this case, all these solutions and all the ones greater than 5 both make that true. Now here's a compound inequality. Again, we're asked to solve this, and it's written without the word in there. So we know that this has to be an and. And so typically we would break this up into two separate inequalities using the word and between them. So what's in the middle goes with the left side, and what's in the middle also goes with the right side. And then we solve each one separately, and we have y, and again, that's y is greater than 1, so it's open at 1 going to the right. This is y is less than or equal to 3, so it's closed going to the left. And then it's just where they're overlapping. So again, the answer is just exactly what they have written there. Okay? Here's an OR. So in this case, these are even simpler because they're already separated for you, and you just solve each inequality. So here we'd add 5 to both sides. We'd have 3x is greater than 9, divide by 3, and x is greater than 3. Then I solve my other one. Subtract the 3. 2x is less than a negative 2. Divide by 2, and x is less than a negative 1. So now I have my two inequalities, and it's the word OR. So I have x is greater than 3 going to the right, and I have x is less than a negative 1 going to the left. And again, my answer is everything that's graphed. The graph is my answer there. So again, if we just take a look at a couple more examples. Now, if you only have one variable, and there's only one variable in the middle, you could just keep it like this and subtract 8 from each piece. It's kind of like a three-legged teeter-totter, and you have to subtract 8 from every piece to be consistent. And then we have negative 10 less than or equal to 5x is less than or equal to 10. And now divide each piece by 5. And so we get negative 2 is less than or equal to x is less than or equal to 2. And now if we were to graph that, this is negative 2, 0, 2, maybe close, and it's in between. And that way you don't have to mess with having to rewrite it into two separate inequalities using the word and. But you can only do it this way if the variable is only in the middle and these are just single numbers on the outside. All right? We look at the second example here. My eraser's not working very well. But we look at the second example here. This is an OR, so I'm going to divide by 3. I get x is less than or equal to a negative 4. Or subtract 7. 2x is greater than or equal to a negative 2. Divide by 2. And x is greater than or equal to a negative 1. So I have the OR. So now I graph. So I have negative 4, negative 3, negative 2, negative 1, 0. Less than or equal to a negative 4, so it's closed and to the left. And greater than or equal to a negative 1, so it's closed and to the right. And then again, there's our answer. Now, these type of answers that we're getting, these are the typical answers for our compound inequalities. All right, so this is what we got to have here. All right, sorry for that interruption, but again, when we're solving conjunctions, your typical answer will look like that. When you're solving disjunctions, your typical answer, the graph will look like this. All right? Now, here, we're going to go ahead and solve. This is an OR. So I subtract the 1 here, and I get 2x is less than or equal to 12. Divide by 2. I get x is less than or equal to 6. Here I'm going to add the 5. I get x is greater than or equal to 0. So now I go to graph this. And again, this is an OR. So I graph this. I'm going to graph it up above here. And I have 6 is here. 0 is here. And less than or equal to 6 would go this direction. Greater than or equal to 0 would go this direction. Now, the problem is it looks like it's a disjunction because they're overlapping, but this is an OR. And if an OR overlaps, that means that everything is included. The whole number line is included. So my answer is all real numbers. So if you have a disjunction that overlaps, your answer is all real numbers. Now let's look at this next example. This is an AND. Subtract 3 from each side. I get 2x is less than 4. Divide by 2. X is less than 2. Here I'm going to divide by a negative 3. And remember, when I divide by negative, I have to remember to reverse that inequality sign. I get x is less than a -3. So, in this problem, I have a -3 here, and I have 2 here. And in this case, they both are going in the same direction to the left, and so this is an and, so when they begin to overlap is not until here. And so my answer ends up just being this one inequality, x is less than -3. And so our graph would only have the -3 open and less than. Now, that's a non-typical type, and typically, we won't do a lot of those types, but that's just, again, showing you the difference of what can happen when you're solving compound inequalities. Now, the one thing I do want to point out, though, is if you have a and the two graphs do not overlap, then we would have a no solution. So if you're graphing an and you have one going this direction and one going this direction, and they don't overlap, then that would be a no solution. And so the two non-typical types that we need to make sure we know is that if an and does not overlap, it's a no solution. And if an or does overlap, it's all real numbers, right? So that concludes the video for tonight. I know there's a lot of information there, and we're going to spend Thursday and Friday kind of reviewing this and going over this in class. So again, have a great evening, Titans, and be ready to get after it tomorrow.
Made with Doodlecast Pro.